The settings in the material section. So for printing temperature, I've got a little video showing sort of what different temperatures look like. So at 175 degrees, you notice the layers are real inconsistent. It's because whenever it's trying to extrude at such a low temperature, the filament is actually not quite liquid yet. So it's still pushing through a filament that's kind of too thick to be pushed out. At 205 degrees, you'll notice the layers, they get real uniform and they look like there's no gaps between, so there's some good adhesion. And then at 275 degrees, you'll notice that it's just so fluid. The filament is so liquid, it's just kind of oozing everywhere and not maintaining its form. A lot of people will print a temperature tower that you can download at Thingiverse. Um, to check the particular type of filament that you have, what's the best temperature for it. But usually, from what I've seen, it's between 190 and 205. Somewhere around there is going to be your best range. Um, the build plate temperature, I right now have it set at 60, but I generally have it set at 70. The reason for this is a lot of people, they complain about initial layer adhesion. So they'll notice that their print actually starts to lift off of the build plate. The reason for this is because the plastic, when it's heated and printed, it, it's expanded more than it would be if it was cool. So as it cools down, it contracts, and as this print is contracting, um, the print will actually become misshapen and it'll cause it to lift off the plate. Well, if the plate is warm and it keeps the print warm, it's actually gonna it won't actually misshape while you're printing it. Another way to avoid this is to put it into a box and keep the box at a good solid 70 degrees Celsius or something like that. Um, the diameter, the filament that you buy should have the millimeters that however the diameter is. But what I would recommend doing is the particular filament you have, checking the diameter in 10 different spots, and then adding it up and divided by 10 to get an average of the thickness. And it just so happens to be that the filament I'm using actually was 100 or 1.75 millimeters. The flow rate, I always leave this at 100%. A lot of people try to fix layer problems by messing around with the flow rate, but that's kind of the hacked way of doing it. I wouldn't even mess with that at all. I would just leave it at 100%. And then enable retraction. Um, I would recommend always enabling retraction, or else you're going to have stringing. Like some of your prints are, uh, they're going to have really bad problems stringing. Let me see. I know I've got. Okay. So for your retraction settings, here's a little graph that shows retraction speed versus retraction distance. And if you'll notice, what the heck am I doing? At a low retraction distance, you're still getting this stringing coming off of this model, right? When you get to a higher retraction distance, you'll notice there's less stringing. And then at a lower print, you'll notice the quality of the print altogether, the slower speed of retraction, the quality of the print altogether is kind of hurt by it. Same way, if your print is too fast, you're going to notice little air gaps and stuff. So to me, the sweet spot looks to be about 6 millimeters at a faster speed or 8 millimeters at a slower speed. These three right here kind of look best to me. So I put mine at 40 millimeters a second, and then the retraction distance I put at 8 millimeters. That seems to work for me. The retraction extra prime amount, what that means is whenever you retract and then you start to print again, how much how much volume you plan to print. So the reason why I have this set at negative is because my prints had a bad problem with blobs and zits. So one of the things you can do to help fix blobs and zits is have a negative extra prime amount. Let's see if I can find this here real quick. Right here. So I got the recommendation from this website from Simplify 3D. So right here it was recommending putting a negative 0.2 millimeter extra prime, or what they're calling an extra restart distance, negative 0.2 millimeters. So that actually helped eliminate those blobs and zits, like right here. Retraction minimum travel distance. So what that's going to do is it's going to say at what distance are you going to retract. So if you have a print that has these large gaps and small gaps, you're setting the distance at which it actually will retract or not. So with the settings on here, it's saying here's the minimum travel acquired, minimum travel not acquired. So at these small gaps, it won't even retract at all. It'll just continue to, it'll just stop printing for that time and then continue to print. And then it'll actually retract here, not retract here. So for these small gaps, you're saying don't even bother retract, because it'll, if you have a lot of these small gaps, it's going to drastically increase the time that it takes to print, because it's going to say, okay, I have to pull the filament back 8 millimeters before I can actually start printing again. I have to pull it back, then refeed it, and then start printing again. So if you have a lot of those little gaps, and if you want it to be a good quality, you're just going to have to accept that it's going to retract here. So you would say if this was a 0.1 millimeter gap, you'd have to say my distance is 0.1 millimeters. But if you kind of fine with there being a little bit of stringing here, then and you're worried about the overall time of the print, then you would say anything 0.1 millimeter and smaller, don't even bother retracting. Maximum retraction count and the minimum extrusion distance window, these kind of play on each other. So when you pick your minimum extrusion window, you're going to say, I want within 8 millimeters of filament, I only want to retract a maximum of 90 times. The reason why this is a setting is because, where's that? There it is. So a lot of times the filament can get damaged by the extruder, by the gear that feeds the filament into the extruder. So if you have a print that's constantly retracting, constantly feeding, it'll actually wear down the filament. And whenever this gets to go be fed in, it's going to be expecting it to be 1.75 millimeters thick, and it won't be. So you'll notice that there's a part of your print. And if this happens to be printing on the outer layer, you're going to be like, well, there's a little gap missing in my outer layer. And this could be why, because it's retracting so many times in that small distance that it actually wears away the filament. Standby temperature, if at some point in time you tell the printer to stand by, you're actually going to want to set it at a low enough temperature so that the filament isn't just oozing out of the extruder. If I had this set at 200 degrees Celsius and it's on standby, it's just liquid is going to be dropping out of the extruder. You're going to want it to go down to about 175 or lower, so that filament isn't dripping out of your extruder. So the nozzle switch retraction distance. If you have a printer that has multiple nozzles, whenever it goes to switch nozzles, you say I want it to pull back 16 millimeters. I don't have like a dual nozzle setup. I only have one nozzle, so I don't really mess around with these at all. But the same thing for the nozzle switch retraction speed, how much it's going to retract whenever it goes to switch. And then same thing on these two right here.